All right, a very warm welcome to all you Druids across the world for our fifth and final session of this fourth Virtual Druid Summit. We've had over 450 people registered from across the world, and unlike in-person conferences, not everyone has bathed today, and that's totally okay. Everybody, you do you. Anyway, I'm Rachel Podreski. I run the Druid community program here at Imply. And we're joined this hour by Jeremy Plichta, who's the Director of Engineering at FullContact. So before we get to hear his wonderful story of Druid and Kafka Streams, a few housekeeping notes. We got some rules around here. So y'all be on mute, except for Jeremy and I, but that doesn't mean you can't get involved. There is a Q&A button down at the bottom of your screen. Do you see it? A little Q&A icon. That's where you can ask questions. I will provide those to Jeremy at the end if we get through them all. Spectacular. If not, we'll do a follow-up blog post to make sure everybody's questions get answered. We're also live tweeting on Twitter if you want to follow that conversation. And links to the full presentation and accompanying slides will be sent out following the session. So watch your inbox for that. So this talk is building a real-time eventing engine at FullContact and will be super interesting for all of us looking for containerized deployment. So Jeremy, over to you.
Thank you, Rachel. I'm Jeremy Plichta. I look very forward to telling you guys about our story about how we've been using Druid and Kafka Streams and how we built something pretty cool with both of them together. So just getting into it, what are we going to talk about today? So a little quick interview of who am I and who is FullContact. It'll give you a little bit of a good context for what we're talking about later. What is identity resolution at a really high level, and what are usage events? Why do we care about them here at FullContact? And then how did we use Druid kind of in stage one for just usage analytics? What did that look like? And then real-time eventing. So once we had usage analytics, what did we do to actually build in real-time eventing off of that to get useful information and actions out of our system instead of just pretty graphs? And then I'm going to talk a little bit about a debugging tool that we built called dstir that helps us figure out what's going on. We also use Druid for that. And then just some other miscellaneous challenges that we faced along the way. So as the title implies, this is about Druid and Kafka Streams. If I'm a little bit honest, I think it's probably slightly more about Kafka Streams than it is Druid, but we couldn't have built this system without really both of them. All right, so who am I? Again, I'm Jeremy Plichta. I live in Colorado, in the Denver area. I love spending time with my family outdoors, doing things like snowboarding when it's not a pandemic. I'm really into learning new technologies, doing hackathons at my company, and finding ways to apply those in real world, real life use cases. I find a lot of cool kind of toys to play with, and that might be a problem if I do that too often. But when I get a chance to take one of those and actually turn it into something useful that is supporting the business, I think that's even better. So I've been working at FullContact almost 2 years. And who is FullContact? So we are an identity resolution company, and I'll talk a little bit more about what that is. But the core of what we do is we help brands and companies better connect with their customers and their consumers. And we have two main products we do that with. One's called Resolve, which I'll talk about in the next slide. And then we have a product called Enrich. So here are some of the logos that my marketing team said I was allowed to put on the slides. So you'll see some CRM-like systems like Salesforce and some direct brands like Time. We have lots of other ones as well. So the reason all of these people use FullContact is to help with the problem of identity resolution. Now, what is identity resolution? So this is the nice product marketing blurb. It's taking fragmented and silo identity and bringing it together. If I turn that into a picture, you can kind of imagine it like this. We might have, if I'm a brand, I might have interacted with somebody that's interested in my product in several different ways, through an email, through a different email they might have signed up, and through other digital identifiers that come into the ecosystem. So if I might have these 3 different views of who I think this person is because I have these different identifiers and I don't know that they're linked together. So this would mean I'm communicating to this person like 3 different people. Maybe I'm marketing to them like 3 different people. When they log in, I'm treating them like 3 different people, and it just leads to kind of subpar outcomes and relationships. So ideally, the problem FullContact does is we take this and we turn it into something that looks more like this to give people a better picture of who they're interacting with. Getting a little bit more on the technical level, how does this happen? We have a close to real-time API that brands can interact with us through. And so we have the user, this is your brand or the other website. They're coming in through our public API. They're passing some context data that's getting encrypted along the way and hashed. Behind the scenes inside our system, we are doing identity resolution using our identity graph, resolving that down to who we think that person is. There's the possibility of adding additional enrichment pieces of data to that. That might be like general high-level information like interests or age or demographics, high-level things like that. And then it will go through a set of data filters because maybe they don't want to know everything. They only want to know these 3 fields of data. And I'm sure you didn't come here to learn about FullContact, but this will help in the talk about why we built this system. So Druid for usage analytics. So we started using Druid in about April or May of 2019. And we just started tracking all of our API requests that are coming into our system. So the little user here that's coming into the API, everything gets written to Kafka in the form of an Avro message. We read off of Kafka and write to S3 and Parquet. And we also read off of Kafka into Druid so we can get that real-time analytics. And then coming out of Druid, we have a FullContact dashboard that we built. And that lets you see your API queries and group it by things like data packs or response status. Also would let you do things like unique API queries, looking at the hashed identifiers. So you could know, like, did I query for my email address 1 million times during this day or 1 million different email addresses during this day? So using a hashed identifier and then the hyperlog log, we can get that really good approximation really fast. And then more importantly, or at least for this talk, is we can compute the total cost of the query. So how much is this costing our end user that is a subscriber of our API? So what does the dashboard look like? This is a screenshot that I took out from our public dashboard. This is my user account. I don't have a ton of usage. So this is showing on different days I had 7, 6, 5, 4, 3. This is pretty low. And I'll talk about what actual total usage looks like. But as a customer, I can come in here and I can make API requests and refresh this page, and I instantly see those reflected in my usage counts, my usage totals. So this is just a really powerful tool for both customers and our internal users alike. So this is a custom application that we built that is querying Druid, but there are some open source tools that we're using as well internally. So this is a screenshot of a system called Ternillo. It's an open source tool that you can point to Druid. You can click and drag and drop and filter and come up with all sorts of graphs and just really quickly understand your data. This is, from my understanding, this is the open source version that Imply has, and they have a lot of more bells and whistles that aren't included, but we've gotten pretty far with this, and it helps our users understand the data and slice the data, and we don't need to build specific applications that know how to do all of this. So Ternillo is a really great tool that's been helping us for usage analytics. So let's go back to that word I used. So computing cost. So as a user uses our system, they're making several API queries. Depending on the data that's coming back to them, that costs them a different amount. And maybe that's dollars or matches or something. But the main thing that matters is, we have an agreement with them of you can use this much data during this contract billing period, and we want to track that over time. And we want to do that in real time. And because we want to know when they reach that maximum cost query that we both agreed to. So when they reach that, we want to disable service really quick time so we don't have people run over their limits and kind of run our systems down. So we also want to calculate that total cost as new usage appears. We want to be updating it continuously. So usage, your total cost can change if you get new usage. It can also change if the pricing rules change. So this doesn't really happen very often, but we can go back and change the definition of how much a API request costs, and it's different for each customer. That is an event as well. A usage is an event. So all of these events are driving this real-time system. And importantly, we wanted the system to be asynchronous. So if you go back to that kind of flow diagram where they make a request to the API, we don't want it to be asking every single time, like, am I there yet? Am I there yet? Am I there yet? And looking it up. We wanted to have this happen outside of the API flow, but we wanted results to be quicker than once per day or once per hour. We wanted it to be continuously happening. So how did we do this? So we took two things. We used Kafka Streams and we used Druid. Kafka Streams, high level, it's a client library for building kind of applications and microservices where all of your input data is in Kafka pretty much, and your output data is mostly in Kafka. So you're taking one or more streams of data, you're doing something interesting with it, and you're outputting more streams of data. And then Druid, we also are using as well. So you saw earlier in our architecture that we're putting this into Parquet and Athena. And so I guess you could say, well, why aren't we just using Athena instead of Druid? Druid gives us a lot of advantages for this real-time system. So we're making pretty heavy use of roll-up features in Druid. So we can have really just gigabytes of data instead of scanning terabytes and terabytes of data in Athena. And the response times are just really, really quick. And since Druid is a columnar storage format with indexes on pretty much everything, this use case where we're saying, all right, for this specific customer, I want to aggregate their usage. Since that customer is a dimension on account ID, it can really quickly filter the usage that we care about in those time windows. And it all just happens much faster than it would if we were actually using Athena directly. So I don't think Athena would have worked for this real-time use case. Jumping back to Kafka Streams again, the other thing I like about Kafka Streams is it compiles down to a normal JVM application that you can run anywhere you can run a normal JVM application. So you don't need a Spark cluster or a Flink cluster. You don't need to manage any of that. You can just deploy it the same way you would deploy any normal microservice. And we're doing that using Kubernetes. All right. So what does this real-time eventing system do? How does it calculate that kind of cost and keep that cost up to date? So we kind of have two things that happen. This is supposed to be a little bit of a timeline. So if you start in the middle with where we say stream start date now, that is the event that kicks off all of the interesting things we're going to talk about. So that's a usage event coming into our system. And that is what we're calling the stream start date. And so from that point forward, Kafka Streams can keep track of the ongoing aggregation for that account. It knows the total number of requests. It knows the total cost that it needs. But we have things that occurred before this stream start date that we want to know about. So when we start this, we query Druid. We do this asynchronously for that specific account. And we ask Druid for the beginning of the billing cycle up to like right now, this second, what is the usage aggregation that occurred during that window? So Druid will come back with the response. And like I said, it's asynchronously, it comes back onto a different internal topic. Using Kafka Streams, we join those together. As part of this, we also query a metadata service that is going to tell us how do we compute pricing information. And then going forward, we can keep that real-time rolling aggregation in Kafka Streams. And we make use of Kafka state stores, which are persisted using RocksDB. So RocksDB is this really efficient storage format, which happens locally on all of the Kubernetes pods, but it's also backed up on the Kafka brokers. So our entire application can go down, it can come back up, it can restore the state. If something changes about that user's billing period or that billing contract, that entire aggregation is no longer valid, and we're going to have to wipe that out, start from that point again, and query Druid. So we have several different restart and fallback mechanisms here. And I mean, the queries to Druid are under a second. So it's very quick. It doesn't slow our process down very much at all. So what are some of the steps? I might have gone over some of these already, but let's see. So we're continuously reading usage as it comes in from the usage topic. So API FullContact.com, we go to our usage topic in Avro. We are reading off of that. We're ingesting into Druid for our real-time data. We're also ingesting directly into our multiple instances of our Kafka Streams app at the same time. So again, I already discussed this. We're going to need to look up what does that initial aggregation look like asynchronously. And then we need to know how much does each query cost from our metadata store. That'll come back asynchronously, and then we're going to join that back together. And And we need to update our current cost aggregation. And we will send that to an output topic. And when things are over cost, we'll send another message saying, hey, we have something that's over cost. So as you can kind of see, there's multiple different events that can drive this. There's multiple, I mean, I'm talking about the system at a really high level, but when you're looking at a Kafka Streams app, it's represented as a DAG, or a directed acyclic graph, where you have different processor steps. So you have input data, you might have steps where you join data, you might have steps where you persist data to a local store, and then at the end, you might have one or more output topics that you're writing to. So this stream processor app has grown to be quite a complicated thing with a lot of inputs, a lot of processing in between. It calls Druid, it calls some internal web services, it's storing aggregations, it's outputting to multiple topics. And so when we were building the system for the first time, it was great because we had all of these tools. We had Druid, we had Kafka Streams, but we realized that this is a complicated system that we ended up building. And there's a lot of inputs, there's a lot of outputs, there's a lot of in between. And the side effects that happen are, a customer is no longer able to use our API, or their billing information changes. And so we wanted to be confident that we would know what would happen. And when you're dealing with so many inputs and outputs and moving parts, we wanted to build a debugging system so that if we ended up kind of getting ourselves in this situation where if you imagine each one of these cars is a message in our topic, and something's gone horribly wrong, and you're not sure how to get out of the situation, and you're not even really sure how did all of these cars become facing sideways and backwards. You have no idea. So, I mean, it would be nice if you could sort of like rewind what this looked like and see the state of each one of these cars at a different point in time before, so you could understand the exact sequence of events that led to this outcome. And this is the same thing we wanted to do for our application. So we called it de-stirring the streams. And I debated whether to find a Ghostbusters Don't Cross the Streams reference or not, but I decided the cars was enough for now. So what is de-stirring the streams? It's just a debugging tool that we built to help us along the way when things went wrong. And to be fair and to be honest, we've been running the system for a long time now. Things aren't really going wrong anymore, but in the beginning, this helped us out quite a bit. So how did we do this? So we have all of these things on the left. These are just Kafka topics that are either topics that are directly being produced by our Kafka Streams app, or they are intermediate topics that we're using, like repartitioning topics or topics that are coming back with the Druid response. There's multiple things going on here. So all of these are going on to Kafka. We're ingesting these into Druid, into their own different data sources with keys for what account it belongs to and the time that this event happened. And then we have an internal web app that we built called dstir that can query Druid for these multiple data sources. It can say, I'm interested in this specific customer in this specific time range, and it will pull back all of these pieces of information from those different data sources and put them in the right order so you can see very clearly this happened, and this happened, and this happened, and that led to the end result of this other thing happening. So this has turned out to be just extremely useful for us as we've been iterating on this application. All right, let's see. So what are some of the challenges that we faced along the way? I'm getting towards the end of the presentation here. We can hopefully go to questions here pretty soon. So a lot of these, actually all of these are Kafka Streams oriented, but I'll go through them pretty quickly. So Kafka Streams allows you to do something called exactly once semantics. And so this is a way to guarantee to you that if you read an input message, you do a bunch of processing on it, and you do an output message, you're only going to process that input message and do an output for it exactly one time. So if something screws up in your code in between, you're not going to end up reading that message twice. You're not going to end up writing multiple other messages twice. And this was important for us when we were building this aggregation system. We didn't want to double count messages or anything like that. So Kafka uses a feature called transactions. It's a very similar concept to a database transaction, where it just takes your beginning operation, your end operation, and then it commits your operation, and then your message is written. And I'm not a Kafka Streams expert, but that's high level description. What we found out is that if things go wrong, if your broker, your Kafka broker, is really busy crunching away on a lot of other pieces of work, or if your DAG has a point in your DAG where you're calling some sort of web service and you're slowing down your entire stream, you're slowing down your entire transaction, your transactions can time out and be invalidated by the broker. And the broker ends up fencing you off or saying, no, you took too long. I'm no longer listening to you. I'm no longer going to allow you to commit to it. And that leads to just bad states where you're no longer writing data. You need to restart your application. So we learned to recognize these and to make our DAGs a lot quicker and more efficient. So again, going back to topologies. So this is another Kafka Streams term. I talked about the directed acyclic graph. We've self-admittedly ended up building a little bit of a mono stream application. There's a lot of logic. And I think in that DAG, there's about 40 or 45 different specific nodes in that DAG with multiple branching points, and understanding how is my data actually flowing through, what is going on is a little complicated. So there is a way you can ask Kafka Streams to kind of describe and dump your DAG out, and it will print a kind of ASCII art description of it. And then there's a great tool we found on GitHub that someone made where you can plug in that ASCII description of it and actually draws a useful little graph for you so you can understand what's going on. So I mentioned earlier that we are deploying all of the software using Kubernetes. We are running an instance of our Kafka Streams app, one for each partition, just like you would do for a normal Kafka type consumer group. And the default way when you use a deployment operator in Kubernetes, when you want to deploy a new version of your software, the default deployment strategy is a rolling deploy. So let's say you have 3 instances of your application up, you're deploying a new application, it's going to bring up one new instance. So now you'll be at 4. It'll wait for that one to be up and running, and then it will kill the old one. It'll bring up another one. It'll wait for that to be up and running. It'll kill the old one. This is a really good strategy when you're trying to deploy a microservice that is serving traffic. But when you are deploying Kafka consumers, every time this happens, they go into a rebounce situation where they realize, hey, we have somebody new join. We need to redistribute the work. And while we're redistributing the work, we're not reading off of the topic. And then as soon as they figure out who has the work, it introduces another one. So we realized this is like about the worst way you could deploy a Kafka Streams app. But luckily, there is another strategy you can tell Kubernetes to use, which is just recreate. And that just says, hey, I have a new instance or a new version of my software. Just kill all of the pods. That's fine. They'll come down. The offsets are all stored, so we don't have to worry about losing data. And then once all of the pods are down, bring up the 3 new instances at the same time. So that's worked really well. The last issue, and I was debating or not whether to put this on here, so it's not on the slide, but I'll talk about it a little bit. We are using, Apache Druid, just open source Druid. We're hosting this ourselves. So we recently updated to Druid 0.20. We've got a lot of useful features out of that. But during the deployment, it pointed out a few ways that we could be doing things better, and using better data replication, and the way we do our rolling update process could be better. So when we did update, we had a short period of time where we had partial segments loaded and being served out. And that led to, if you go back to where we're gluing the results from Druid into the results from Kafka Streams, those results coming back were partial. And so it was leading to a little bit of incorrect logic. So we're looking into how to correctly deal with that going forward in the future. So that's really all I have. But thank you for your time, and I'm ready for any questions that you guys might have.
Well, thank you very much for that. That was really cool. And I think I'm a little bit like you, where like you see a new thing, you're like, ooh, let's check out this thing. So, and of course, the first question is about identity graph. How is your identity graph implemented? Which was, of course, my question too. Ooh, are you guys using a draft database? And if so, which one and why? But the question actually just is the identity graph implemented as a graph DB?
So it's not really using a graph database. We're using a lot of different technologies. And the cool thing about FullContact that I really like is they built this whole identity system like from the start to work from API and to work well with batch. I didn't talk about batch, but that's where somebody sends you a big file and you want to do identity resolution on it. So we are very heavy users of Spark and EMR. And then we build that graph and we resolve and we look at all those connections, we run all the algorithms and take it. I'm not on the identity team, but I can talk about it from a high level. And then we build kind of reverse indices into that graph, and we build H-based clusters that power our APIs. So that's where the real-time APIs come in place. And then we're also exploring for other pieces of our system more recently. We're starting to use Cassandra and Scylla for different pieces as well.
So many questions, but I'll keep with the ones that people have asked. So in one of your slides, you had Druid feeding case streams and doing aggregations in case streams. Could you walk through what kind of aggregations you would want to do after the data moves into historical nodes and keep track of in case streams versus what kind of aggregations you would compute before it makes it into the historical nodes?
Yeah, I mean, that's a good question. I mean, I guess the easy answer is that the aggregations are pretty much almost the same thing. They're very simple, like running sums and running totals broken down by kind of by customer and data pack. The one thing that is going into those output messages is that pricing logic. So that's not going into the historicals. The other, so even though it's doing very similar things, we didn't want to be querying Druid like every few seconds or even every hour to say like, all right, what are they at now? What are they at now? What are they at now? So even though we're performing a lot of almost the same aggregations, it's just happening continuously, and we don't have to put that burden on Druid to respond to it every few seconds. Does that help address that, Rachel? To you? I don't know.
It's a question, so they have not written a follow-up question. We actually are out of questions. I think if there's anybody else who has anything else they want to ask Jeremy, I will ask you in the meantime. Why'd you choose Turnleo over Superset, for example?
That's a good question. I mean, we do use Metabase. We haven't really looked too much at Superset. I've been to a few other meetups. It looks like a good tool. Ternillo looked really geared around Druid and like really geared around doing those drag and drop in different dimensions. So it looked really tightly integrated. And if there's no questions, I also have some other information that I thought people would ask about, like number of requests and cluster size and things like that. So
that's always super interesting. There is actually one last question, and then I definitely want to hear about load and all those bits and pieces. Two questions. Does any of the identity resolution logic occur within Druid?
Not right now. We are starting to use Druid for more and more use cases. And so we're kind of using it as a BI tool as well, but we're not using it for identity resolution right now.
And then another question, which you and I actually talked about before the session started, but have you looked into using KSQLDB?
I have read some blog articles on it, but we are not actually using it. I played around with it. From my understanding, it's a way you can write SQL-like code, and it compiles down to basically a Kafka Stream app and lets you run it. So I think it would be useful, especially we're producing a lot of output data in the systems, but we can't always anticipate how somebody's going to use it. And so there's always simple transformations that we might need to do to break out pieces of information before we flow it back into Druid. So I think KSQLDB would be a good tool to investigate for that.
All right, so you no open questions right now. So yeah, any data you have, we get tons of questions in the community channel on load and sizing. So it's always good to see what everybody's doing there. So if you don't mind,
yeah, I can share some of that. And I've seen a lot of impressive presentations from other companies where they're doing like billions of events per day and all of this craziness. And we are not in that realm. We're around 20 million events per day. But looking back historically in Ternillo, there's internal testing and things we've done. We've spiked up to 200 million events per day. And we're doing this with a really, pretty small Druid cluster. We only have 2 data nodes, and there's C5, 2 extra larges. They have some EBS attached. And we're running, I think on our production cluster, we're running 4 real-time ingests from Kafka. And then we have a separate Druid instance for sort of like internal people playing around with and making queries. We didn't want to bring down our production system by people messing around. So we have a different cluster we call it the data warehouse cluster. And we have 11 Kafka ingest streams going on that one. So it's pretty small, but that has let us kind of, I don't want to say be lazy, but get away with actually not tuning Druid terribly, and we're still getting really great performance.
Well, I think it's important that people know that Druid doesn't have to be used for like the world's largest use cases. It can be used for medium-sized use cases, and really successfully. It can grow with you, or it doesn't have to. But like you said, you don't have to tune it out of, to an inch of its life, right? It works really well, sort of out of the box for most stuff on a fairly small cluster. All right. Well, what does Druid give you that other similar databases don't? I am new to Druid. I personally am not, but the person answering.
Yeah, I mean, it gives us the ability to do sort of those pre-rolled up aggregations. So instead of keeping a record for every single usage event, it's collapsing those down into what I call buckets, but Druid calls dimensions. So things that have the same dimension are within the same minute. It can just flatten that down to one record with your count or your sum or whatever metric you want to be calculating in that. So that makes you scan over a lot smaller amount of information. So your scans happen more quickly. Everything's indexed and uses, I listened to one of Gion's talks where he talked about how you're using, I don't know if it was bitmaps to represent where the data is. So everything just is really quick. And with 20 million requests per day, I mean, that's on the medium data scale. It's not big data, but storing that in something like MySQL, I think would get pretty unwieldy pretty quickly, and we don't really want to do that. So
yeah, friends don't let friends use relational databases for stuff like this. I've spent many years trying to make that happen.
Yeah.
The D-stir in Druid seems like an elegant way to debug streams without introducing Elasticsearch, Logstash, etc. Do you do unstructured free text searching, etc. in the D-stir or other analysis besides time series indexing?
That's a good question, and I forgot to talk about when those data streams that are part of D-stir. Some of them are pretty high volume streams, and we don't need to keep all of it. And so I think we have like a retention period of like 4 or 5 days on those, but that helps us debug what's going on during those 4 or 5 days. We have pretty well-defined dimensions. So we have things like the event type, the customer ID that it happened on, but we also usually have like just a blob of extra information that we call details, which is just JSON. And that sort of lets us do free text, or it lets us see what the event looked like. It doesn't allow us to do any easy aggregations by what's in that JSON, but we can still pull it out. And I would say this probably isn't Druid's strong point, like doing scans, but for this purpose, we're using it to do scans, and it works for us, but we're not keeping that data around forever. And we're not scanning over all of it. We usually can narrow it down to just the customers we care about.
And do you do nightly data reconciliation?
Daily and nightly reconciliation? So can you just read the question one more time?
Yeah, sorry. Do you do nightly data reconciliation?
Okay, so we're persisting this data in Druid, and Druid has its own segment file format. We're also persisting the data in Parquet, which we query with Athena. When it's in Parquet, we have like raw level information. So there's some pieces that we don't care about and that we actually don't want to have in Druid, like the encrypted payload, because that would cause a super high cardinality because everything would be different. So we don't ingest every single column. But if we're going back and doing like some in-depth analysis, we might need to go and look at that data and decrypt it. So it's at row level in Athena or S3, and we're writing that with CCore, and we have nightly jobs to compare, is the count in CCore or S3 the same as the count in Druid? And it should be. And we've been running into some weird stuff lately, but that's as close to nightly reconciliation as we do. We don't load that back into Druid. And then I guess maybe a similar question, almost all of our data sources in Druid are real-time updated by Kafka. As we're starting to explore some of the BI use cases, we're starting to do some like batch daily imports into Druid of smaller data sets. But really, even with those, we're importing some data from Mongo. We might eventually be importing some data from Salesforce for BI. It would be nice if we could stream those to Kafka using Kafka Connect and just have those going into Druid on an event-wise fashion instead of batch.
Oh,
drink some water.
Well, that'll be next year's talk is when you get that one done, because that sounds pretty cool.
Maybe.
Well, of course, there's some weirdness in your data lately. It's 2020, so
Yeah.
What would you expect? All right. Well, thank you very much, Jeremy. This was awesome. Really appreciate your time today. And for all you in the community who asked questions, thank you for participating. The links to the slides and the recording will follow. So our next summit is planned to be held in January 2021, which sources tell me is not 2020. So woohoo! So be on the lookout for an invitation in the near future. Don't forget to email community@imply.io as well as getting your name and lights on the project's Powered By page. We'd love to set up 5-minute interviews, blog posts, speaking spots, meetups, virtual or otherwise, and share the latest information on the Apache Druid community activities across the world. Keep an eye on the Imply blog, ASF Slack, the Google user groups for announcements about our new discourse-powered community forum. So thank you all for attending and participating today, and to everyone behind the scenes who helped Peter and I look so professional and calm, kind of professional. Thank you to all our speakers today, especially Jeremy, and I've been Rachel Podreski, and you have all been awesome. So good day, good night, and we will see you all next year. Bye.